Ever just look up at the night sky and wonder, like, how did all of this get here? You know, the Big Bang, the universe, everything.
It's a question that's fascinated humans for, well, probably as long as we've been able to look up and think.
Exactly. And that's kind of what we're diving into today, experimental cosmology, how we actually figure out stuff about the universe's beginnings. We're lucky to have some really cool source material, too.
We do. One of the big ones is an interview that Fraser Cain did with Dr. Brian Keating. He's an experimental cosmologist. And, it's really going to give some insights into how we go from these big mind-blowing theories to actual hard data.
Because it's easy to get caught up in all the theoretical physics stuff, it's all very elegant and mind-bending, but someone has to actually build the tools to test those ideas.
Right, absolutely. And that's where Dr. Keating comes in. His focus is on building the telescopes and instruments that measure the cosmic microwave background radiation.
The CMB, that's like the faint afterglow of the Big Bang itself, right? The earliest light we can possibly detect.
That's it. And to do that, they have to build these observatories in some of the most extreme places on Earth. The South Pole, the Atacama Desert.
Because the air has to be super clear and dry, right, to get the best measurements.
Exactly. You're talking about incredibly faint signals from the early universe. So these scientists are battling, freezing temperatures, high altitude.
It's sort of heroic when you think about it, all that effort just to get the data. And that really struck me while I was reading the source material. These experimental cosmologists don't always get the recognition they deserve.
Right. It's one thing to come up with these brilliant theories about, string theory or the multiverse, and those are amazing. But it's the experimentalists who are putting those theories to the test.
Yeah, and Keating actually says something really interesting in the interview. He says, I'm not in the job of proving theories right. I'm in the job of proving everything else wrong.
Which is so key to how science actually works. It's like, you have a bunch of possible explanations for why your car won't start. You don't set out to prove that it's the battery. You try to rule out other things. Is it out of gas? Is the starter broken?
Perfect analogy. And I feel like that's what Keating's really trying to highlight, the importance of those who build the instruments, gather the data. It's all connected.
It is, and it's not easy. I mean, one of the projects he talks about is the Simons Observatory, which is being built over 17,000 feet up in the Andes Mountains.
Wow, that's high. Just getting the equipment and materials up there must be a huge challenge.
Oh, absolutely. It's a massive undertaking.
Yeah.
And it shows the dedication and, frankly, the sheer stubbornness of these experimental cosmologists.
Now, when we talk about looking back into the early universe, it's easy to think about, say, the James Webb Space Telescope and the CMB research as being in some kind of competition, right? Like, who can see further back in time?
Yeah, but actually it's more like they're working on two completely different pieces of the puzzle.
So, JWST is looking at the first objects, the earliest stars and galaxies that formed after the Big Bang.
Right. Hundreds of millions of years after. Whereas with the CMB, Keating's looking at the first light from just 370,000 years after the Big Bang.
So much earlier.
It's a good analogy he uses. He says it's like two different types of microscopes. One lets you look at cells. The other lets you look at the DNA inside those cells. They both give you information, but at totally different scales.
That makes sense. So by studying the CMB, Keating is trying to answer some really huge questions about the Big Bang itself.
Right. Like, was it really a singularity, that infinitely tiny, dense point? Or maybe more like a phase transition?
And what about inflation, that period of a super fast expansion in the very early universe?
Exactly. And they're also looking for evidence of, get this, a quantum fluctuation at the origin of the universe.
We're talking about some seriously mind-blowing stuff here. And even the idea of a multiverse, right?
Yep. And all of this comes from measuring these tiny, tiny temperature variations in the CMB. And importantly, looking at how the light is polarized.
Polarization. That's how light waves vibrate, right? I vaguely remember that from physics class.
It's actually a really powerful tool for cosmologists because the way that ancient light is polarized can tell you about things that happened in the early universe. Like, did it pass through magnetic fields or interact with certain types of particles?
It's amazing to think those subtle signals are still there billions of years later.
It is. It's like forensic science, but on a cosmic scale. Oh, and you know what else is really cool about Keating?
What's that?
He gives away pieces of meteorite.
No way.
Seriously. Tiny fragments of the Campo del Cielo meteorite from Argentina. He even jokes that they might give you mild superpowers.
That's fantastic. It's such a great way to connect people to space science. It's not just abstract theories anymore. It's something you can hold in your hand.
Exactly. Yeah. And it really shows how Keating is, a true public scientist. He's passionate about sharing this stuff with everyone.
His YouTube channel is great for that, too.
Yeah.
I mean, he breaks down some seriously complex topics in a way that makes them understandable. Neutron decay, for example.
And he interviews Nobel laureates, which is so cool.
It's all about inspiring the next generation of scientists, especially those who might be more hands-on, the builders and tinkerers.
Yeah, he wants them to know that you don't have to be a purely theoretical genius to make a difference in science. As he says, you can build stuff and be a discoverer.
Which brings us back to that key point. Science progresses by disproving things. It's not just about coming up with cool new ideas.
Right. It's about challenging what we think we know, putting those ideas through the ringer of experimental data. And sometimes, that means our favorite theories get, well, disproven.
Which can be tough. But it's how we get closer to the truth and how scientific consensus actually changes over time. Have you ever thought about that? It's not just people suddenly deciding to believe something different. There's a whole process.
There is. And, for anyone who wants to delve deeper into Keating's work and his perspective on all of this, I highly recommend his book, Losing the Nobel Prize. It sparked some great discussions.
His YouTube channel, too, it's full of fascinating stuff.
Definitely a great resource for anyone interested in, experimental cosmology and the whole process of scientific discovery.
So, wrapping up today, we've really seen how crucial experimental cosmologists are to our understanding of the universe. It's not just about those big, elegant theories. It's also about the people who are out there building instruments, gathering data, pushing the boundaries of what we know, and often doing it in some of the most challenging environments on Earth.
It's a great reminder that science is a process. It's about testing, refining, sometimes even completely overturning our ideas about how things work.
Mm-hmm.
And those who build the tools gather the data. They're a vital part of that.
It really makes you wonder, if our understanding of something as fundamental as the Big Bang is constantly being revised, what other truths that we hold dear might need to be re-examined? What assumptions do we make in our everyday lives or in our understanding of the world that might not actually hold up under scrutiny?
It's a powerful question to ask yourself.
Right.
And it's a testament to the power of evidence-based thinking no matter what field you're in.
So much to think about. And for me, that's what makes this whole exploration of the cosmos so fascinating. We're constantly learning, constantly revising our understanding.
It's an adventure, for sure. And for you, the listener, it's an adventure you can be a part of. Just by keeping that curiosity alive, keep looking up at the stars and asking those big questions.
You never know what amazing discoveries might be just around the corner.
You never know.
Thanks for joining us for this deep dive. Until next time.
See you then.